Those Space People, a podcast series of casual cosmic conversations with people working on exciting space projects. Today, we have Barbara Imhoff with us. Barbara is the co-founder of Liquifer, a new space company in Vienna, Austria. Liquifer works with space agencies across the world on space habitation and exploration technologies and similar advanced research areas. Liquifer's team is transdisciplinary, and Barbara is a space architect, among other things. Hello, Barbara. Welcome to the show.
Hello, Rachana. Thank you for having me. I'm quite excited to talk to you about Liquifer's work and space architecture in general.
So your background is in architecture. Can you tell us what led you to space and then eventually what led you to form Liquifer?
Yes, I am a trained architect. Actually, I have a degree from the University of Applied Arts in Vienna. And I've been studying at various schools in Europe and abroad, in London, Los Angeles. And then after my studies, I added a Master of Space Studies at the International Space University in Strasbourg. But basically, I got intrigued by the future of humankind already during my studies here in Vienna at the University of Applied Arts, where I had a teacher, Wolf Prix of Coop Himmelblau, and he always motivated us to think further, to think into the future, to think about a future architecture, to think in very experimental terms. And so I think that during this, I became very interested in technology and future developments. And so already during my diploma, I was trying to create scenarios about where we would live in the future, how we would live in the future, what kind of societies, what kind of architecture would these kind of societies need. And then if you think further and further, then you have to include creating scenarios for living on the moon, for living on Mars, just beyond the Earth's atmosphere. And I think this sparked my interest in researching what can be done on these extraterrestrial terrains and how the environments are there. And through research and some mentors, for example, the Johannes Ortner from the Austrian Space Agency at that time, he actually recommended the Master of Space Studies at the International Space University. So I think that is when my space architecture involvement took off. I also had the opportunity to work at NASA on the Bioplex project, which was a test bed for a Mars mission. So a Martian base, which NASA wanted to build as a simulator. And I was one of the architects designing this facility. And yeah, I think then I became very interested also in teaching. I started a teaching job. At the same time, I founded an architecture office, which was more looking into architectural prototypes and experiments and interventions, urban interventions and the arts. And at the same time, I was setting up a space architecture course at the Technical University in Vienna. And with my ISU network, I was able to sort of channel it into the Office for Space Architecture, which was the subtitle of Liquifer in 2003. At the International Space University, I got to know Susmita Mohanty, and she was also very excited about designing for space and architecture for space. And I think our common interests then led us to found the first space architecture office in Europe. So this is how Liquifer started. And later on, or 2 years later, we established a company with my partners Waltraud Hoheneder, and then later René Václavicek joined. So this is 3 partners, and with an interdisciplinary team with 2 space engineers, with scientists, and sometimes we also collaborate with artists. We have been developing concepts, prototype for humans living beyond the Earth's atmosphere, but also trying to create sort of spin-offs or concepts for a better living here on our planet.
Wow, that's thinking way ahead into the future. It's extremely fascinating. How is space architecture different from terrestrial architecture?
Well, I wouldn't say that it's any different. In its core, it's really about creating environments for humans and animals to live in. I think what is different in that sense is that space, when you think about creating habitats or space stations or bases for extraterrestrial surfaces or for spaceships, then you always have to think about the resources and how to create a good environment with limited resources. You have to think about self-sufficient systems, and you also have to be very creative with using a very minimal space. So I think these three components, they comprise the parameters, the so-called spaceflight parameters. And this is quite interesting because it becomes more and more vital for our terrestrial living as well.
What is the architectural perspective during design of space systems? How do you look at them?
I think what is also a little bit different is that it's really a coming together of the environmental specifics. So space is a very unforgiving, very harsh environment. We can't breathe in space. We have to create these little biospheres around us, so spaceships or bases. And then we also have to think about the human and what the human needs. So we need fresh air, we need water, we need food, of course, but then we also need an environment where we feel comfortable and which allows us to live in a good way. So what is that? I think we need private spaces, but we need also common spaces where we all can meet. We need maybe some spaces which are a little bit in between, semi-private or semi-public spaces. And despite the fact that we have always an extremely limited volume available to incorporate all these different things, I think it's important to foresee all these different corners and sections within a small spaceship, because this is how we live. Humans need a space for retreat, but they also are, very social people. And so there's also maybe gathering around a table for a common dinner or so. So these are very specifics which we need to plan for as well.
In your long career, you must have worked with a lot of engineers from various disciplines. How do engineers and architects look at things differently? Because being an engineer, I'm really curious. I'm sure there's a whole dimension that I'm missing out when I look at space systems design.
I think that architecture always starts with creating an environment for humans. So the human aspects, the human behavior, the human psychology, physiology is always at the center, despite the fact that some architectural, more experimental architectures are now heading towards an incorporation of other creatures, animals, for example, or microbes or so. We also try to incorporate as entities, but just to keep it a little bit more simple for now, I think this is how architecture and architects start to look at. We look at also aesthetics is of our concern. And I think that the actual development of a design, of an idea, of a concept for this environment, this is always at the beginning of planning for space, but also for our planet. And I think we also think a lot in scenarios. So we imagine, there's this group of people and they're going to live in space for 1 month. So what do they do there? They will work on their experiments. They will have to maintain the spaceship, but also they have some leisure time. What do they do then? And what would they need? So this is on top of the basic needs, which is, air and water and food. And the engineers, I think they're, even amongst the architects, so even the engineers come in all different kinds of flavors in that sense. So I think that some of them have a very high value for aesthetics as well. And they're used to design systems, but I think that they are looking for the designing of the machine, the life support systems, for example. And so that is a very different aspect. The starting point, I think, is different. But what I always find interesting is that one always meets engineers who have a very high regard for the actual human designing the human environment. And so it's in an ideal sense, I think architects and engineers can work together quite well. They complement each other. So the architects need the engineers and the engineers need the architects. And I've also observed in the last years that, there are more and more, like I say, architects working also in the engineering realm and the other way around, especially with space projects, which are highly complex and they are often, large projects, and there are a lot of different people and entities from different professional backgrounds, cultural backgrounds, countries. They all come together for one project. I think that is when also sometimes, the professional boundaries are sort of more merging into each other or permeable.
Liquifer works with the European Space Agency and other research institutions. So can you tell us what kind of projects that you work on?
We run this company in Vienna, Liquifer Systems Group, since 2005. And we have also most recently established company Liquifer Space Systems in Bremen. So especially with our office and our company in Bremen, we are working currently for the European Space Agency and for Thales Alenia Space to design the interior of the International Habitat Module for the next space station, Gateway. Gateway is an international program. It's run by the International Space Station partners, who include NASA, who is also the lead on this project, then the European Space Agency, the Canadian Space Agency, JAXA, the Japanese Space Agency, and probably also Roscosmos. So these partners, they have already established a legal framework for collaboration, and hence they're also collaborating on this lunar orbiting station Gateway. Gateway is seen as a gate to open up exploration of the moon because it's orbiting the moon, so it's very close for landing on the moon, but it's also pushed out further than the International Space Station. So it is in a much more unforgiving environment with high radiation. And there we can also learn how to protect humans from radiation and from more micrometeorite impacts. And this will be a very good test bed for going to Mars. So its Gateway is, as its name already says, it's a door to further exploration to the lunar surface and then to Mars.
So Liquifer also worked on terrestrial projects. Can we call these spin-offs from your work on space projects?
Well, in our Liquifer philosophy, we really don't draw a line between Earth and space because there is no boundary. It's a continuum. And Earth is part of our solar system, part of the universe. So we even see the population of Earth as astronauts on our spaceship, Earth. That is actually an image which was described by Buckminster Fuller. And so while the space world might want to always create or use the term of spin-offs, we are a little bit more reluctant to do so because for us it's just one thing, and there's different kinds of environments we have to cater for. So we did some projects, for example, the Eden ISS project under the lead of the German Aerospace Center in Bremen, which was to establish a greenhouse in Antarctica next to the Neumeier 3 station. Neumeier 3 is the German research station in Antarctica. So 400 meters south of that station, we built the greenhouse, which is a test bed for future missions to Mars or to the moon. But at the same time, it also actually provides fresh food to the crew of the Neumeier 3 station, who lives all year round in Antarctica. But especially in winter, they're completely isolated and they are sort of as if they would live on a spaceship. It's very, very similar. So it's a very good simulation environment for long-term space flight. And at the same time, it really changes the way the crew lives because they have some fresh food just harvested food to eat. And they also have this green space where you have flowers blossoming, when it's in full bloom, everything, it looks a little bit like a jungle, a small, tech jungle in a way. And I think that also adds to the psychology and to the well-being of the crew at the Non-Maya 3 station. This is all, I would say, this all falls into that category of creating prototypes and simulators. And one of the other famous simulator we designed and built was the SHE habitat, the self-deployable habitat for extreme environments, which can be used as a transportable simulator for testing missions, future missions for astronauts on the moon or on Mars. And the interesting part is that the way it's being built and it's being deployed is really a good paradigm or mock-up or prototype for a real space mission, because it could also fit into a large rocket, into a heavy lift launcher.
Firstly, having no distinction between space and Earth is a really new perspective for me and something definitely to think about. After listening to this podcast, I'm sure a lot of people would be interested in pursuing a career in space architecture. So what is the skill set required to pursue a career in this domain?
Well, as I mentioned before, that the space environment is a very interdisciplinary environment. So a lot of disciplines come together. So I think for architects, it's very vital to understand the other disciplines. That starts with terminology, with language. But of course, it also starts with knowing technical systems, maybe knowing legal frameworks, knowing policies, knowing politics in that area. So I think that is quite a wide range of knowledge which has to be acquired beyond the knowledge which one would get through studying architecture. It's also vital that one has experience in building stuff, whatever. It's always good to have participated in construction projects, smaller or larger, on Earth, so one knows what, because there are all these different parts need to get together: the plumbing, the facade, the all the installations, and the interior, etc. So I think that is always a good prerequisite, knowing that and being able to also maybe lead such efforts, and that is a good prerequisite before going to space. On the other hand, there's a lot of new technologies like robotics, 3D printing, programming, which is also good to know about or to have a certain skill set. So my advice would be to not only rely on a traditional architectural education, which is a requirement, but also to extend the education beyond that and add either a Master of Space Studies or a Master in Robotics or something like that.
If students or young space professionals want to reach out to you, what's the best way to contact you?
I would like to refer to a platform. It's called spacearchitect.org. It is a great resource for, first of all, a lot of technical papers about the wider professional field of space architecture. It also includes a lot of technical papers on space designs. And it has some resources where people can look where to do space architecture courses, where to study, and also get to know other professionals in the field. There's an association created with it, spacearchitect.org, the same name, and that can be also joined. And so people can get access to a large international network of space architects. I myself can be contacted through our office at liquifer.com, and anybody who's interested and who thinks has the required skills can, of course, also send an email.
Thank you very much, Barbara, for sharing us this fascinating insights into the amazing world of space architecture.
Thank you, Rachana, for inviting me. It was a pleasure talking to you. And I hope you have many more exciting podcasts to follow and to create a large base for you, the listeners on space.